Hey everyone, welcome to this explainer. Today we're looking at the absolute heavyweights of Earth observation satellites, and we're going to see how they actually team up to form the ultimate tag team for scientists worldwide. If you're into tracking our planet from orbit, looking at everything from crop health to shrinking glaciers, you are in exactly the right place.
So let's jump right in. The core question every single remote sensing pro has to ask is, which orbital eye in the sky is actually the right tool for the job? Because as we're going to see, these satellites are definitely not built the same.
We're looking at a classic head-to-head matchup. In one corner, you've got the pioneering Landsat program, specifically Landsat 8 and 9, managed by the legendary tag team of the USGS and NASA. And in the other corner, the agile, newer Sentinel-2 satellites run by the European Space Agency. Here's our roadmap. We're going to compare their stats across 5 categories: the Earth observers, spatial resolution, temporal resolution, spectral bands, and geometry. Then we wrap up with how they actually work together in something called harmonization.
All right, Section 1, the Earth observers, a shared mission. Let's get a quick introduction to these sun-synchronous, near-polar orbiting powerhouses. That fancy orbit just means they pass over the same part of the Earth at roughly the same local time, which gives us perfectly consistent lighting.
Landsat brings a really massive half-century legacy to the table. Landsat 1 launched way back in 1972. But our focus today, Landsat 8 and 9, went up in 2013 and 2021. Sentinel-2, on the other hand, burst onto the scene way more recently. We had Sentinel-2A in 2015 and 2B in 2017, and they were designed to perfectly complement our global monitoring. Moving to round 2, spatial resolution, the sharpness. Think of this basically as the megapixel count of our space cameras. How much literal ground detail can we see? Notice the differences here. Sentinel-2 generally gives you higher resolution. Its main visible and near-infrared bands capture details at a super crisp 10 meters, with red edge and shortwave infrared at 20 meters, and atmospheric bands at 60 meters. Landsat 8 and 9? They give us a remarkably reliable, moderate resolution of mostly 30 meters, alongside a 15-meter panchromatic band and 100-meter thermal bands that are typically resampled down to 30 meters. So, the real takeaway here: if your study area needs you to track really small-scale changes, like the subtle shift of a coastline or a tiny farm boundary, Sentinel's 10-meter pixels are going to give you that extra crispness that a 30-meter pixel just might blur out. Okay, Category 3, temporal resolution. The speed. This dictates how fast these satellites can orbit and snap a brand new photo of the exact same spot. We call this the revisit time. A single Landsat 8 satellite has a revisit time of 16 days. Yep, over 2 weeks to get back to square one. But if you team it up with another operational satellite like Landsat 9, that wait drops to a much more manageable 8 days. Sentinel-2, meanwhile, runs its 2A and 2B satellites together and just zooms around, giving us full global coverage every 5 days. For fast-changing situations, think sudden floods or rapid insect infestations, that 5-day speed is an absolute game-changer. Round 4, spectral bands, the vision. You can think of these as the specialized sunglasses these sensors wear to see invisible light. Sentinel-2 has up to 13 bands, while Landsat 8 and 9 feature 11 combined. Just look at how brilliantly this overlap illustrates their relationship. They share 7 overlapping bands. It proves they see the world in very similar ways across the visible and near-infrared spectrum. But there are a couple of massive distinctions on the far ends of the spectrum. The biggest one? Landsat boasts exclusive thermal infrared sensors to literally measure Earth's surface temperature. Sentinel-2 entirely lacks thermal capabilities. But Sentinel fights back with specialized 20-meter red edge bands, which are just unbelievably good for monitoring plant health. Getting deep into the technical weeds here, they even do their math differently. Landsat 8 calculates its center wavelengths using what's called the full width at half maximum method. Sentinel-2, it relies on a completely different approach, likely a weighted average. It sounds like a tiny nuance, but it's totally vital for scientists crunching the raw data. On top of that, Sentinel-2 rocks a dedicated band 9 at 60 meters just for estimating atmospheric water vapor. Landsat doesn't have a water vapor band at all, so it literally has to rely on external auxiliary data, like CAMS data, just to perform atmospheric corrections and cut through the haze. Section 5, geometry and swath, the scope. This is all about how they physically capture imagery while hurtling through space. Both fly in sun-synchronous near-polar orbits, but Landsat uses a push-broom design to capture 185-kilometer overlapping scenes. Sentinel-2, though, is famous for its high-resolution, wide-swath imaging capabilities. Basically, they're scanning the Earth using totally different viewing geometries. Which brings us to Section 6, Harmonization. Better together. This is the climax of our explainer. What happens when we stop treating these machines as rivals and start treating them as teammates? Magic. That's what happens. Check out this map. This is 24 hours of Earth observation using only Landsat 8. You see the sweeping orbital paths, sure, but look at those massive black gaps left across the globe. Now watch what happens when we toss Sentinel-2A and 2B into the mix. Boom! The gaps shrink dramatically. Suddenly, the Earth is wrapped in a much, much tighter net. And through the Harmonized Landsat and Sentinel-2 project, or HLS, NASA actually processes the Sentinel data to perfectly match the Landsat data, aligning it all onto a shared military grid. Combine Landsats 8 and 9 with Sentinels 2A, 2B, and the new 2C, and almost the entire Earth gets covered in a single day, the ultimate tag team. By beautifully combining these distinct sensors and effectively tweaking Sentinel's spatial resolution slightly to match Landsat's 30 meters, scientists have achieved an unprecedented cloud-free revisit time of just 1.6 days. So with petabytes of data freely flowing from this harmonized mega collection to track ice velocity, monitor crops, and assess natural hazards almost in real time, we gotta ask, what previously impossible discoveries are we gonna make about our planet tomorrow? The sky really isn't the limit anymore, it's just the starting line.